One of the things that 802.11ac does is it delivers a higher level of modulation, and it goes up to 256 QAM. And you're like, what does that mean? So the easiest way to look at that is to take a look at some illustrations. And so let's take a look at BPSK, which is 1 bit per modulation symbol, or what I always like to say is 1 bit per waveform. So you're transmitting over the air in a given frequency channel, and that waveform is representing your bits. And what I do is I say, okay, if I change the phase this way, it represents a 1, and if I change the phase by 180 degrees, it represents a 0. So as long as you can detect that phase difference when you receive it, you can say, oh, that was a 1, or that was a 0. And so that's all that modulation is. It's just representing 1s and 0s in waveforms. But I can go up to higher levels of modulation. So I can go to QPSK, which is 2 bits per waveform. And you see here, instead of using a 180-degree phase shift, I'm now using a 90-degree phase shift. And so if I use a 90-degree phase shift, well, that gives me 4 phase shifts. 360 degrees in a circle, 4 phase shifts. Well, if I have 4 phase shifts, then I can represent 2 bits per waveform. So now my waveforms going over the air, same frequency channel, is sending 2 bits rather than 1. I just doubled your data rate. Well, why don't I keep going? Well, of course I keep going. I go to 16 QAM, which is now going to go to 4 bits per waveform, and it varies the phase and the amplitude. That's what QAM means, is quadrature amplitude modulation, changing the phase and the amplitude. I can go to 64 QAM, 6 bits waveform. Why don't I keep going? And so with AC, they said, yes, you can keep going. You can go to 256 QAM. And that allows me to send 8 bits per waveform. And so I can get up to much higher data rates than what I could with N, which only went up to 64 QAM. So 256 QAM, if you're like me with an RF background, you'll go, no way, in a Wi-Fi cell, you just won't be able to use that. And you'll say, I've only ever seen it in a microwave connection where you're using parabolic dishes and very narrow beams. Well, remember with 802.11ac, I've now got beamforming. So, when I'm sending out the beacon, well, for the beacon, maybe I want to use a lower level modulation because I want to cover right across the cell. But when I'm transmitting to an individual user and I'm using those beams, well, then I can get up to higher levels of modulation. So you can actually get to 256 QAM, actually quite far away from the access point. And so it's not just in the area very close to the access point. And of course, with my beamforming, I can move the beams as the users are moving. So I'm able to get a much higher data rate, much better user experience by introducing a higher level of modulation. I'm just super excited by this because I've never seen it in this kind of environment, and it's going to be so much fun to play with.